Hello and welcome to this R-Instat video on climate normals, mainly about precipitation. The calculations described here are based mainly on the WMO guidelines. Their adaptation and implementation in the US are also considered. Climate normals are calculated for 30-year periods ending in 0. Those from the US are shown, together with the information of the enviable number of stations for which they are available. The WMO distinguish between reference normals and climatological normals. They propose 1961 to 1990 be considered as reference normals, and hence should remain available. Climatological normals are for the most recent 30 years, and so should soon be for 1991 to 2020. Conveniently, these two periods will no longer overlap. WMO distinguish between principal and secondary parameters. The 8 principal parameters include rainfall totals and the number of rain days. These principal parameters are all essentially averages, but it is important to recognize that climate variability is normal. This aspect must be included, and particularly for precipitation. Hence, for rainfall, WMO propose quintiles, and these include the extremes. Also, the number of days with more than specified limits. These are just guidelines. Countries should consider which to use and which to adapt. For example, the table from Chicago in the US from 1981 to 2010 shows minor changes from the WMO suggestions. For precipitation, the totals are given, as are the number of rain days. The limit for a rain day is changed from 1 millimeter to 0.01 inches, as inches are still used there. The different thresholds suggested by the WMO are replaced by a single 25 millimeter or 1 inch threshold. For the whole year, we see that the normal total of 993 millimeters was from 123 rain days, of which 9 had more than 25 millimeters. The WMO suggested quintiles have been replaced by quartiles. For example, in June, with a mean of 103 millimeters, 25%, or 1 year in 4, had less than 3 inches, and 1 year in 4 had more than 5. The 4 inches, or 103 millimeters, came from 10.3 rain days, so 10 millimeters per day, of which, on average, just 1 day had more than 25 millimeters. Data from 2 stations in Ghana are used to illustrate these calculations. Precipitation normals are shown here, with temperature normals in the following video. Here, for the rainfall, there is hardly a problem of missing values. The WMO guidance on coping with missing values is considered separately. The data here are suitable for either the reference normals from 1961 or for the climatological normals from 1981. The starting point for each country or organization is to have a set of checked data for all the stations in a single file, such as is shown here. We just have 2 stations, but this could easily be 20 or more. For precipitation, a preliminary step is to get a rain day variable, as shown here. We use the WMO definition of 1 millimeter, with the slight adjustment to 0.85 millimeters. This allows for rounding problems and for data transformed from inches to millimeters. Use 0.95 as the threshold if you don't agree with these reasons. return and add a further variable for a day with 5 millimeters or more. We change the threshold to 4.85 and rain day to rain day 5. Then click OK again. A 10 millimeter and 25 millimeter threshold has also been added. We added these off camera, as the process is the same. Now select the years for the climatological normals. Right-click and choose Filter. Define a new filter and choose Year and make a condition for the year to be bigger than 1980. Add the condition. Then choose Year again and set it to be smaller than 2011. Add this condition as well. Then return with the two conditions. Then choose to apply as a subset and give it the name Ghana Normals. This makes a new data frame with the years for the climatological normals. It starts in 1981 as shown, and the precipitation variables are ready for analysis. The total number of rows is almost 11,000 per station, which is about right for 30 years of daily data. The first stage towards the normals that we saw from Chicago is to get monthly summaries. This uses the Climatic Summaries dialog. Use the Annual and Within button, then include rainfall and the month factor. Now click on the Summaries button. Untick N total and choose Maximum. Then press Return and OK. Good, that seems to have worked. Add the number of rain days before examining the results in more detail. Go back to the last dialog, put the 4 rain day variables into the receiver. Then, in the Summaries tab, just keep the sum. From the results we see, for example, that in June of 1983 at Salt Pond, there was a total of 81 millimeters from 12 rain days, of which 5 had more than 5 millimeters, and there was just one day with more than 10. The largest amount on a single day was 30.5 millimeters. Now the second stage. This is initially to average over 30 years. This isn't yet in the climatic menu, so uses the more general summary dialog. Include all the rainfall and rain day variables. Then get the results by station and by month. In the summaries, just get the mean. There is the occasional missing value, so tick this box. Here are the results. So, how do these results compare with Chicago shown earlier? There in June, there was a mean of 103 millimeters from 10.3 rain days, with a mean of just over one day of more than 25 millimeters. Here from Tamale in June, the mean was 148 millimeters from 9.2 rain days, of which 7, 5 and 2 had on average more than 5, 10 and 25 millimeters of rain. So far, the normals with R-Instat are all averages. Variability is evident in the Chicago normals with the quartiles. In R-Instat, use the same dialog and simply tick the quartiles. Give them for both the monthly totals and the number of rain days. Extremes are also possible. Go back to the dialog, add the max rainfall, and choose maximum instead of the quartiles. So now there are 12 monthly normals for the precipitation. For example, for June at Tamale, the upper quartile for the monthly rainfall total is 192 millimeters, while the maximum is 289 millimeters. There were never more than 12 rain days in a month. Finally, the largest single day rainfall was 112 millimeters. It would be good to show some of these results graphically. In the supplement, we show the steps to produce this graph of the normals for the amounts. The bottom line shows that the monthly minimums have been added and are the bottom line in the graphs. Then there are the quartiles, the mean, and also the maximums for each month. This second graph shows the normals for the number of rain days with the different amounts. For example, the orange for August in Tamale shows quite a number of days, usually with more than 25 millimeters, while this is quite rare in August in Salt Pond. The third stage is to give seasonal or annual normals. In relation to the Chicago normals, we've reached here. The annual results given are just averages, so the mean year had 993 millimeters of rain from 123 rain days, of which 9 had more than 25 millimeters. The annual quartiles are not given. The WMO guidelines shown here are for the monthly normals to be used to produce the annual values. We follow this instruction for the Ghana data, though for precipitation it does not permit quintiles, quartiles, or most extreme normals to be given. Use the summary dialog again with the monthly normals as shown. We add the rainfall sum variable as well as the 4 rain day variables. We summarize by station, and in the Summaries tab, we only keep sum. This gives the 5 normals at each station, and just one of the extremes is possible on an annual basis. To do this, we return to the dialog, clear the receiver, add the maximum rainfall variable. Then in the summaries, we uncheck the sum and select maximum. So at Salt Pond, the mean annual total was 945 millimeters, with an average of 67.9 rain days, of which an average of 12 days had more than 25 millimeters. The record daily rainfall was 215 millimeters. In a supplement, we show more details of the calculations in R, including those needed to produce the graphs. In the next video, we'll show you calculations of temperature normals. Thank you for watching. Bye.